1981 Cadillac engines, drivetrains, brakes, and suspensions create a story comprised of outstanding technological contributions to automotive engineering. With new applications of solid-state electronics, new developments in engine control and diagnostic systems, new computer-assisted designs in chassis and suspensions, and new designs in brake system components. Of course, much of this year's effort has gone into making the 1981 Cadillacs fuel efficient with reduced emissions. In response to federal and California mandates, Cadillac set a division fuel economy target for its vehicles. To reach its goal, Cadillac has virtually redesigned from the ground up to preserve the Cadillac virtues of comfort, convenience, and value while responding to the fuel efficiency requirements of the 80s. Taking a look at 1981 Cadillac engines, we find that there are three base engines. The 6-liter V8 6.4 digital fuel-injected engine on DeVille, Brougham, Eldorado, and Limousine. The 5.7-liter V8 diesel engine on Seville, and the 6-liter carbureted V8 on the commercial chassis. The 4.1-liter V6 engine is available as an option on all Cadillacs, except the Limousine and commercial chassis. The 5.7-liter diesel is available on DeVille, Brougham, and Eldorado. Among the many engineering feats these engines represent, probably none stands out more than the 6-liter digital fuel-injected engine with a cylinder selection feature that enables 4, 6, or 8-cylinder operation, depending on conditions. The modulated displacement function of this engine is achieved through the use of 4 valve selector units, electromechanical devices that are capable of simultaneously deactivating both valves of the cylinder, which are controlled by the DFI electronic control module. This illustration shows the cylinder head and valve mechanism in both the active and inactive conditions. During active operation, the fulcrum or pivot point is near the center of the rocker arm, as would be the case in all conventional valve train mechanisms familiar to Cadillac. As the cam reaches its high point, the valve is brought to an open position and allows the fuel charge to enter the cylinder. The view on the right shows the cam also on the high point, but the valve has not opened because the selector solenoid has been issued a command to release the rocker arm pivot to allow it to move upward. This, in effect, shifts the fulcrum point to the top of the now stationary valve stem and results in the valve being held closed by its spring. When a cylinder is rendered inactive, its intake and exhaust valves are both held closed at the same time, while the remainder of the valve train is allowed to operate through its normal travel. Valve selectors such as this installed on cylinders 1, 4, 6, and 7 are controlled by the ECM to allow 8-cylinder, 6-liter, 6-cylinder, 4.5-liter, or 4-cylinder, 3-liter operation. Varying the size of the engine in this manner makes it possible to effect significant reductions in the internal work the engine is required to perform, resulting in fuel economy improvements averaging 10%. This engine has many electronic advances, all of which rely on the 1981 array of sensors, which has been augmented and which sees many of the carryover sensors redesigned to improve connector retention and electrical integrity. The vehicle speed sensor was added because the electronic cruise control logic has been incorporated into the capacity of the ECM on DFI vehicles. The oxygen sensor because it is the heart of the 1981 closed-loop fuel control system, which utilizes the dual-bed catalytic converter introduced on some 1980 model Cadillacs. These three components perform the key functions of the 1981 DFI system. The ECM provides the central processing unit and input-output controls. The modulated displacement driver assembly functions as a relay, providing power to the valve selector solenoids upon command from the ECM. And the range module works with the ECM to operate the MPG Sentinel when the range button is depressed.
The 1981 MPG Sentinel panel displays instantaneous miles per gallon to the nearest whole MPG, average miles per gallon to the nearest 1/10 MPG, expected fuel range, and active cylinder operation.
To accomplish all of these functions, the 1981 electronic control module has been expanded to 2,000 words of calibration memory, 100% more powerful than 1980, and to over 12,000 words of program memory, 50% more than 1980. But the real story for 1981 is in the greatly expanded diagnostic capability built into this system, which now boasts 47 trouble codes and switch tests, 23 more than last year. The system displays 11 different engine sensor and control values. It also provides on-command activation of various engine control solenoids to further supplement diagnostic accuracy. Diagnostic modes can be easily entered or exited according to the specific requirements of a given failure code, using only the necessary steps of the sequence. This chart diagrams the entire diagnostic system, from the engine sensor malfunction display, codes 12 through 68, through the 70, 80 series of switch checks, to the 2 series new for 1981, the 90 or engine data series, and the 95 or select actuator series, which includes 96, the actuator cycling series, and 97, the cylinder select series. Let's look at the trouble code display, which is capable of detecting 35 different DFI malfunctions. Further, these malfunctions can be identified as hard or intermittent, and the ECM can automatically revert to fail soft or limp home operation for many of these conditions. In 1981, the code 70 represents a decision point from which several different diagnostic sequences can be initiated. One of these tests is the switch check series, which by cycling certain switches allows the ECM to complete its diagnostic checks with the help of the technician. All of the switch checks were carried over from 1980 into 1981 and augmented with 4 new ones. The 90 series engine data check is all new for 1981. After completion of the trouble code series or switch test, various engine sensor and control parametric values can be displayed on command. In many cases, the trouble trees will indicate that a test in this series is required to complete diagnosis by determining such values as throttle angle, manifold, and barometric absolute pressures or injector pulse width. Code 95, actuator selection, enables a technician to activate various engine control solenoids using ECM command signals. From code 95, the technician can access codes 96 or 97. For code 96, the engine is off, during which the ECM will activate 2 groups of solenoids. First, one group and then the other is automatically activated for 3 seconds by the ECM. This continues for 1 minute, during which time the technician can physically feel the valves operating and determine that the electrical wiring is carrying the command signals. The system then reverts to code 95, from which the technician can proceed to code 97, the cylinder select test. With the engine running and the vehicle either stationary or being driven, the 8, 6, or 4 cylinder modes of operation can be selected manually by pressing certain MPG Sentinel buttons. Now let's watch the system in operation. The diagnostics mode is entered by pushing the off and warmer buttons simultaneously. The temperature setting is replaced by 2 dots and then an 88, indicating that all segments of the display are operating. Any and all engine sensor malfunctions will be displayed sequentially and repeated once. At the end of the second sequence, a 70 will be displayed, as in 1980. Also, if all tests are good, a 00 will be displayed, followed by a 70. To enter code 90, engine data, the cruise control enable switch on the instrument panel is turned on-off. Each parameter is called up with a push of the instant average button. The number of the parameter precedes the analog value
for about 1 second. Parameter 1 is throttle position, usually within 0 to 31 degrees. Depressing the accelerator, we can see the position change. After the last parameter, pushing the instant average MPG button will allow proceeding to code 95. When the code 95 is displayed, either 96 or 97 can then be entered.
For code 96, the engine is off. For code 97, the engine is running. For both, entry is gained by depressing and releasing the accelerator pedal. At the completion of the sequence, or at any time, the diagnostic mode can be exited by pushing any button but rear defogger. Another significant feature for 1981 is the addition to the 6-liter DFI MD system of the improved electronic cruise control, with the electronic controller being incorporated into the ECM. For the customer, improved set speed holding accuracy will be apparent, reducing momentary speed loss on uphill grades to a minimum. And as we have seen, the DFI ECM does provide diagnostic capability for malfunctions of the cruise control system, although the check engine light will not illuminate to alert the driver. Turning now to the available 4.1-liter V6 engine, we find new levels of sophistication in the 1981 computer command control system used to accomplish the fuel control required for emissions and fuel economy. The 1981 system retains the essential features of the closed-loop design included in the 1980 C4 system, where the ECM monitored unused oxygen in the exhaust and changed fuel flow to maintain an air-fuel ratio as close as possible to 14.7 to 1. New features are added in 1981 to provide more precise control of fuel usage and performance, including electronic spark timing control, and for C cars, torque converter clutch controls, and engine detonation spark correction. The ECM analyzes numerous inputs and provides output commands to control such functions as the C-car anti-detonation system. When detonation signals are sent from the engine detonation sensor to the electronic spark control, the ESC modifies the EST signal, retarding the spark advance 4 degrees per second until the detonation stops. In addition to its primary assignment regarding emissions control, the 1981 computer command control is capable of detecting, recording, and indicating malfunctions within the system in essentially the same way as in 1980. When a malfunction is detected, the ECM records it in the form of a trouble code and turns on the check engine light in the telltale strip to advise the driver that a problem has occurred. In the case of an intermittent, the check engine light will go out while the ignition is still on. However, the related trouble code is retained in the ECM memory. Assessing the diagnostics involves a new procedure. This assembly line computer link, or ALCL connector, located between the ashtray bracket and the glove compartment, has 5 pins. Jumping pins D and E together activates the diagnostics. Now let's turn to another very strong Cadillac engine story, the 5.7-liter V8 diesel, which has been given refinements for 1981, such as the roller tappet camshaft, which reduces engine wear in this critical area. Using roller lifters, the 3,000-mile oil change interval can be increased to 5,000 miles. This will significantly reduce the maintenance expense for high-mileage drivers. The second refinement is the reduction of engine noise and emissions during cold startup by advancing the fuel delivery system on 49-state diesel engines. When the engine temperature is below 120 degrees Fahrenheit, a solenoid in the injection pump advances the fuel delivery 3 degrees to provide slower, more complete combustion. The 49-state 1981 diesel engine uses an internal EGR system to control the output of oxides of nitrogen, whereas the external system used in 1980 and carryover on 81 California diesels had tubing mounted on the engine as an add-on system. The internal system features exhaust passages cast in the cylinder head,
and air crossover similar to the EGR system used on gasoline-powered engines. A redesigned crankcase ventilation system has been developed in conjunction with the internal EGR system to reduce crankcase pressure at idle. The last major change for 81 diesel engines is the addition of a fuel line heater, which is activated when the temperature drops below 20 degrees Fahrenheit to reduce the possibility of paraffin buildup in the fuel system. This chart tells the 1981 generator story. The 80 amp generator is standard on DFI and diesel. The 100 amp unit is standard on DFI with defogger and available on the diesel. The 70 amp generator is standard on V6 with or without a rear window defogger. All 1981 gasoline C cars come equipped with the 25-gallon fuel tank to deliver the convenience of additional driving range between refills. Now, let's turn our attention to transmissions. Cadillac utilizes 4 different transmissions with 9 different model designations for 1981. The Turbo-Hydromatic 400, the Turbo-Hydromatic 325, and the Turbo-Hydromatic THM 200C in the same applications as last year. And the new THM 200 4R, which replaces last year's THM 350 on C-Series cars equipped with the V6 engine. Now let's look at the benefits offered by these transmissions. The THM 200C provides a wider gear ratio coverage with a torque converter clutch applied in 3rd gear to improve efficiency by eliminating converter slip, thus delivering improved fuel economy while being 36 pounds lighter than the THM 400. The new THM 200 4R is a dramatic addition to the Cadillac lineup, offering wider gear ratio coverage, overdrive in 4th gear, electronically controlled torque converter clutch applied in 3rd and 4th gears, improved fuel economy while being 20 pounds lighter than the 400. Vehicles equipped with the 4-speed transmission are equipped with this shift indicator. In drive, all transmission speeds, including overdrive, are available. In 3, 3rd, the same 1-to-1 ratio or direct drive with 2 upshifts is possible, but overdrive is eliminated. 2, 2nd, provides only a 1-2 upshift. 1, 1st, keeps the transmission in a manual low gear with no upshifts possible. For all other transmission applications in 1981, the shift indications will take this new look. The sometimes confusing drive left, drive right, and low callouts are gone, replaced by D for drive, 2 for manual 2nd, and 1 for manual 1st. Also, the word park is no longer spelled out on either shift indication. Now let's move along to other components in the drivetrain, such as prop shafts. All C cars will use a new low-mass propeller shaft. This is a Cadillac-specific single-piece shaft that utilizes single cardan universal joints, which reduces mass by 4.5 kilograms, provides freedom from vibration, and minimizes wobble by means of Cadillac's specific attachment to the rear axle. With the new propeller shaft, rear control arms can be selectively punched at attachment points to ensure control of long-term car-to-car tolerance variations affecting joint angles. Rear height of the transmission, which also affects joint angles, is regulated by selective shimming. Lubricating the slip yoke is not required on the 1x1 propeller shaft. However, it is required on the carryover from the 1980 model limousine and commercial chassis propeller shaft. The 1981 standard axle ratios, the only axle ratios available, show the 2.41 to 1 on the C, E, and K cars for the 6-liter gasoline engine and the 5.7-liter diesel engine. The 2.93 to 1 for the 4.1-liter V6 engine on E and K, and the 3.23 to 1 with the V6 engine on the C cars. The limousine and commercial chassis vehicles use the carryover 3.08 to 1 ratio. The final drive assemblies on the Eldorado and Seville are of a new design that leads to a fuel economy improvement of 1/4 mile per gallon. Next,
Let's look at brake systems, where we find improvements on C, E, and K car systems. For 1981, all C cars have new low-drag front disc brakes which improve fuel economy under certain driving conditions. Low drag is achieved by redesigning the front brake calipers to allow the lining to retract further and decrease its rubbing action against the rotor. This diagram shows the small change in the front caliper seal groove that pulls the piston and linings further away from the rotor when released, resulting in lower drag. For gasoline C cars, a new quick take-up master cylinder is required to provide the proper feel on the initial application. This new master cylinder has a larger 40-millimeter diameter section in the bore to provide additional fluid to actuate the front calipers faster and is similar in design to the one used on 1980 E and K cars. The C diesel engines continue to use the hydraulic brake booster, which features a larger diameter master cylinder to provide the additional piston travel. C cars have their rear brake drums graphite coated in production to help balance front disc and rear drum performance during break-in. New service procedures detailed in the service manual are required when replacing linings or turning a brake drum. Eldorado and Seville brake systems have semi-metallic front brake lining material previously used only on diesels. This maintains brake system performance with the new low rolling resistance tires. Important changes have taken place in tires. Advances in tread and carcass construction, as well as polymer changes in the tire tread and sidewall, combine to create a tire that absorbs less energy as it rolls along the road surface. An optional suspension system for 1981 is the FE2 touring suspension for the Eldorado and Seville to make available an international spirited automobile with more cornering ability, more roll control, and improved steering precision. Specific elements in the package include increased ride and roll rates and shock absorber damping. The steering has more feedback and effort, and the tires are the same as those presently found on the Chevrolet Corvette P225 70R 15s. The DeVille and Brougham make available a heavy-duty suspension package for a firm, well-controlled ride on rough, deteriorated, or unimproved roads, which is aimed at the prospect who appreciates the ride control offered by high-performance automobiles. As we have seen, top to bottom and from the inside out and the ground up, the 1981 Cadillacs offer a multitude of new designs and new features, with revisions in virtually every area, which means new service procedures, new part numbers, and new areas every service technician needs to know. That's why this schedule of 1981 Cadillac training is being offered at all 32 General Motors training centers. 2 days of digital fuel injection, 2 days of computer command control, and 2 days on the new 4-speed automatic transmission. Be sure to enroll now, and best wishes for a service-full 1981.